Welcome to another exercise for the workbook Statistics, this time focusing on measures of dispersion. So let's have a look at the exercise. Here we have Hans owns a whiskey collection. The bottles in his collection have the following age statements. And we get here this information on the different bottles. Our tasks now, first off, calculate the range, the interquartile range, the corrected variance, and finally the corrected standard deviation. However, before we start this, in particular aiming at part A and B, we're going to reorder our data set. So I'm going to start with the original data set, and then I'm ordering this in an ascending fashion, meaning from smallest to largest value. So here I'm starting with 12, another 12, so forth, until I get to the largest values, the 25s. So this is my ordered data set. This will make part A and B, the range and the interquartile range, much easier to determine. So if we start with the range simply is, as we see in this formula, the difference between maximum and minimum. Maximum being 25, the largest value here, minimum, the smallest value. So it's simply 25 minus 12, giving us 13 as the range. So that was relatively easy because we already saw what's the smallest and the largest value. However, the next part, the B, with the interquartile range, is similarly easy. Again, we're using the ordered data set, and for the interquartile range, I have to calculate 3 quartiles, meaning I have to calculate the third and the first quartile, or in other words, the 75% quantile and the 25% quantile. Getting those two values by first off calculating 0.75 times the number of observations. Then, depending on whether this result is integer or not, I'm going to calculate the value I'm going to use here. Well, assuming this is not an integer, so point something, I'm going to round up. Independent of what the point something is, even if it's 0.01, I'm still going to round up. That's what these half brackets actually mean, always rounding up. If for some chance I will get a value which would be integer, then I'm using a different formula. But well, let's start taking a look here what we get first. So if I multiply the 0.75 with the observations, which in this case is 9, I'm getting 6.75. And if I'm multiplying 0.25 with 9, I get 2.25. As I said, in both cases, I'm going to round up. So here I'm getting 7 and here I'm getting 3. Well, then I only have to look up the 7th value in my data set and the 3rd value in my data set, meaning I'm going to take the 23 and I'm going to take the 12. Taking the difference of those two gives me 11, which then is my interquartile range. So again, we can see that it made sense that first off we ordered our data set. As I said, this works in a similar fashion as long as here I'm getting something which is non-integer. Well, that's the case here, and it's quite often the case. Well, this takes care of part B, so let's turn to part C. In part C, where we need the data again, we're going to calculate the corrected variance. Here we actually have two different versions we can approach this problem with. In both versions, we're going to need the arithmetic mean. The arithmetic mean simply adding up all the observations, dividing them by the number of observations. So here we get 18.1111. Then, as I said, we can proceed in two different fashions. The version I'm going to use here is actually the second version, which means I'm going to calculate first off all the squared observations. So I'm going to take all of this to the power of 2 and sum this up. That would actually be the sum I'm going to see here. And if I'm doing this with values, That's this first bracket. That's summing up all the squared values. Those squared values I'm going to divide by the number of observations minus 1, because here I'm using the corrected variance. So divided by 8. Then I'm going to take my arithmetic mean. That's the value I just calculated earlier, the 18.1 something. I'm going to square this as well. That's what I did here. And multiply this with this correction factor. This is number of observations divided by number of observations minus 1. Again, I'm going to use this factor because at this point I'm working towards the corrected variance. Well, here 9 observations divided by n minus 1, so 9 minus 1 gives me 8. All of this I'm going to put into a calculator and I get as an end result 31.111. Well, that was already part C, the variance. So we could use this formula, as I said. The alternative would be to subtract from each of my observations the arithmetic mean and then square the end result, add all of this up and divide it by the number of observations minus 1. That would be a second alternative. However, here we're going to continue with part D. And in part D, we're talking about the corrected standard deviation. So first, I'm going to copy the variance from part C, because the standard deviation is simply the square root of the variance. So here we're going to take the square root of the 31.1 something, giving us 5.5777. And that's the end result for our corrected standard deviation. So that's actually the easiest part of the whole exercise. Well, this already concludes this exercise, so I hope you enjoyed it. I hope you learned something. I say goodbye and see you next time.